we want to find the formulas for the given sequences, which are either arithmetic or geometric. If the sequence is arithmetic, that means the pattern to find successive terms in the sequence is that we're adding a constant each time, or we can also say successive terms have a common difference given by d equals a sub n minus a sub n minus 1. So if we have an arithmetic sequence, the formula for the sequence will be a sub n equals a sub 1 plus the quantity n minus 1 times d. And if the sequence is geometric, the pattern is we multiply by a constant to find successive terms, or successive terms have a common ratio r, which is equal to a sub n divided by a sub n minus 1. And if the sequence is geometric, the formula for the sequence will be a sub n equals a sub 1 times r raised to the power of n minus 1. So the first step is to determine if we have an arithmetic or geometric sequence. And for these two examples, we should be able to analyze the sequence to determine the pattern. Looking at our first sequence, we have negative 15, negative 12, negative 9, negative 6, negative 3. Notice how these terms are increasing by 3, meaning if we have negative 15 and we add 3, we get negative 12. Negative 12 plus 3 is equal to negative 9. Negative 9 plus 3 is equal to negative 6, and so on. Because we're adding a constant each time, this tells us the sequence is arithmetic and that our common difference d is equal to positive 3. Looking at the formula for d, we have a sub n minus a sub n minus 1, which means if we select a term in the arithmetic sequence and subtract the term before it, we should obtain the common difference d. Notice negative 3 minus negative 6 would be positive 3, negative 6 minus negative 9 would be positive 3, and so on. And notice the first term, a sub 1 is equal to negative 15. This is all we need in order to find the formula for this arithmetic sequence. We would have a sub n equals a sub 1, which is negative 15, plus the quantity n minus 1. Remember, our formula will have n in it, times our common difference d, which is positive 3. So now we'll clear the parentheses, and we'll have our formula. So we have negative 15. We'll distribute 3, so we'll have plus 3n minus 3. So combining like terms, we have a sub n is equal to 3n minus 18, which is the formula for this arithmetic sequence. This formula will allow us to find any term in the given sequence. Now let's take a look at our second example. Notice how the terms are alternating sign, which is an indication that this will be a geometric sequence. We would multiply by a constant to find successive terms. Negative 3 times negative 2 is equal to positive 6. Positive 6 times negative 2 is negative 12. Negative 12 times negative 2 is positive 24, and so on. So because we're multiplying by a constant each time, this is telling us this is a geometric sequence, and our common ratio r is equal to negative 2. Looking at the formula for r, we have a sub n divided by a sub n minus 1. Notice that negative 48 divided by positive 24 is equal to negative 2. 24 divided by negative 12 is negative 2, and so on. And for this sequence, notice that a sub 1, the first term is negative 3. So because we have a geometric sequence, our formula will be a sub n equals a sub 1, which is negative 3, times r raised to the power of n minus 1. So we'll have times negative 2 raised to the power of n minus 1. This formula would allow us to find any term in the given geometric sequence. Okay, in the next video we'll take a look at two more examples that are a little more challenging because the terms in the sequence are fractions. I hope you found this helpful.